Hello friends, and today we will learn how to detect start of a cycle inside a linked list. So in our earlier video, we learned how to check if the linked list contains a cycle or not. Now we will take it forward and we will try to detect what is the starting point of that cycle. In our earlier video, we learned how to find a cycle with two different approaches. One was hashing, another was two pointers approach. In two pointers approach, we were having one slow pointer, another fast pointer, and our detection point was when both the slow and fast pointers were equal inside the loop. Right. Now, the first thing to detect start of cycle is to find length of cycle. Right. Now, how to find length of cycle? It's actually very trivial, and to do that, what we will do, as start and fast they both are pointing to the same node, we will move one of them at a speed of one node at a time, and when the another pointer will again be pointing to the first pointer, each time we will be counting how many nodes were in between, and that would give us length of our cycle. Right. Now let's dry run it. So let's move our fast pointer by one node, 1, 2, 3 and 4. So this shows that length of cycle is 4. Now this means that total length of linked list minus 4 is equal to some remaining step. Now these remaining steps are these one. Right. Now we can write L is length of cycle plus remaining steps k. So let's write it here. L is length and then k is remaining steps. Now starts the interesting point. One thing we can definitely observe is it won't matter even if we take L steps first and then we follow with k steps, or we take k steps first and then we take L steps. It will eventually be completing whole linked list. We will be traversing whole linked list with the help of L plus K steps. Now what we can do, now starts the second part. The first part was to finding the length. The second part is what we will do, we will move both the pointers to the start, right, and then we will move one of them with L steps, right, and then once the first one has taken L steps, then move both of them K steps. Right. This is actually the core of our algorithm. So let me try to explain it in very clear and easier terms. What will happen that first the start and fast, slow and fast, they will be pointing to the start. Right. Now we will move fast by length of cycle, that is 4. So 1, 2, 3 and 4. Now comes the interesting part. So if you observe here, this is K and this is also K, right? How can we say that the remaining part is K, this part? Because we have already taken L steps out of total length. And how can we say this part is also K? Because the remaining part is length of the cycle. I hope you are getting my point. So with the help of this observation, what we will do, we will move both the pointers with K steps, and once they meet, they will be meeting at the start of cycle. Right. Now let's dry run it, and I hope with the help of that you will understand it better. Now let's dry run it with this example only. Right, and we have start here, we have fast here. So we will move, the first step is move both the pointers to the start. That is done. Now we will take 2.1, one of them with L step. So we move fast with L step, that is 4. So 1, 2, 3 and 4, and then we move both them K steps. So let's say this is taking K step and it is also taking K steps, right? And now they have met, so this is start of the cycle. Now you might be curious, how would we find remaining steps? What is remaining step? So the remaining step would be, once you start and you have taken L, and once you have started from here and then you have taken L steps till here, the remaining is K, and so is this part, right? Now we take two different scenarios possible. Right, now say we have the linked list like this, and so in this case the point of L steps would be outside of cycle. Here the point till what F was initially pointing was inside the loop. Here the pointer, here that point will be outside. How would that be outside? Let's see. So the length is 4, right? Now we move both the pointers to the start, and then we move F by 4, 1, 2, 3 and 4, right? Now the point where F is pointing is outside of the cycle. How would it be able to detect in this particular case? Even this will work, right? Now when F will take remaining steps and so will take S, sorry, they will be pointing to the same. So F is taking 1, so is taking, oh, sorry, 1, then F is again taking 1 step, then S is taking here, then F is taking here, then S is taking here, then F is taking here, then S is taking here, then F is taking here, and then S is taking here. So now they have again met. So this is the starting point. The simplest example is showing us that no matter if you take L steps first and then you take K steps, which was done by fast pointer, and no matter if you take K steps first and then you take remaining L steps, that is being done by slow pointer, eventually they both will be meeting at the start of cycle. I hope this example was easier to understand, intuitive, and I was able to make my point very clear. Once you understand how we are detecting the start of cycle, you won't forget it. That's the thing. Once you are able to see the logic behind the curtain, you will not forget in your whole life. I am pasting a link in the description of the question on which you can go and practice this particular question. The link is from Interview Bit website. If you find any problem in understanding how should we proceed in order to solve it, please leave a comment. I'll try to make another video explaining it with the help of pseudocode and the actual working code, but you must give it an honest try before doing that. I hope this video was helpful to you, and let's continue our journey and learn data structure and algorithm in very intuitive manner. Thank you.